Welcome to the second final review video. This video will cover quadratic equations. There are multiple methods, so make sure you take some time to sort through the different methods and when you would want to use them. Here's the first example problem. As before, as I do the explanation, please record any vocab words you think might be important for you to use when you do your final video. The key thing that you should recognize here, in addition to the fact that this is quadratic, again, the reason it's quadratic is because you see an x squared. And this quadratic equation has only one term with a variable. It's an x squared term. So the simplest way to do this is actually to add 20 the other side, and then to take a square root. And the reason that works is because when you take a square root, this exponent and the square root cancel each other out so that you do have x by itself. However, when you take a square root, there are always not just one, but two different solutions, a positive and a negative version. So the answer here is x equals the square root of 20 or the negative square root of 20. Make sure the negative is outside. You should not leave your answer like that. You should simplify the radical. I know that 20 is the same thing as 4 times 5, and 4 is a perfect square. So actually, the square root of 20 is the same thing as 2 root 5. Similarly, the negative square root of 20 would be negative 2 root 5. Some important vocab words that I would have used is probably quadratic. Of course, quadratic means that x is squared. You might want to talk about isolating the x squared. And then, of course, you would use the word square root. And you would introduce the concept that there are almost always two solutions when you take a square root of a number. In your second example, you should notice that there are two x squared terms. The first thing you'll want to do is collect them. You can go either direction, but I'll come this way. When I subtract 4x over here, I get 6x squared. And don't forget that when you subtract the same term, it's a 0. Canceling out means a 0. You shouldn't just put an x there, because then you'll get stuck trying to solve the rest. From here, we want to still isolate the x squared, which is going to involve dividing by 6. But 0 divided by 6 is still 0, so that doesn't change very much. And then this is the exception. The only square root that has only one answer is the square root of 0. And the square root of 0 is just x equals 0. There are no negative or positive zeros. For the most part, you would use the same vocab words to explain this problem. Again, you would talk about collecting or isolating the x squared term. Okay. Number 3 is also a square root problem. Might be a little bit strange looking to you at first. Those of you who recognize vertex form will see the kind of h number inside here. But when you are looking at this, notice that there's still really only one x term. It's not an x squared term immediately noticeable. Some of you might have the instinct to take this parentheses, write 2 of them, and FOIL it out. If you do that, you will still come out with a good answer at the end. But the way I'm going to show you is a little bit quicker. Look what would happen if I take the square root of each side of the equation. I'm allowed to do that because I'm doing the same thing to both sides, and in math, that's always allowed. The square root of this side is going to be x minus 1. And that's because that 2 and the square root cancel each other out. On the other side, the square root of 16 is either 4 or it's negative 4. And so this becomes 2 equations, which is probably familiar from absolute value or any number of other situations where we split this equation. The reason we split this is not just because that's a rule, and you should not say you have to split in your video. You should explain that when you take a square root, there is always a positive and a negative answer. From here, you can easily see that x is going to equal 5 or negative 3. And those are your two solutions. As with before, you could check by plugging these back in. For the most part, I think the vocab words here are the same. You may have thought of some extras or a common mistake, which are definitely worth recording. Number 4 is where it finally gets fun. We've got two terms with x's. We've got an x squared term and an x. You might want to note that this is a quadratic trinomial. And our goal for solving this would be to factor. Please use the word factor. Do not use the word snowflake method. Or you could use both. But factor is the actual term. In order to factor this, my goal is to write this as two binomials, in fact, as the product of two binomials. If you can guess and check, that would be totally fine. The snowflake is a trick to help us find those two binomials, but ultimately you just want to find two binomials that could be FOILed out to give you the original answer. Snowflake method involves identifying A, B, and C. In this case, A is 3, B is -7, and C is 4. A times C goes up here, which is going to be 12. B goes at the bottom, which is -7. A goes on the two sides. I'm now looking for two numbers that multiply to 12 and add to -7. It turns out that -4 and -3 will do the trick. And I'm going to remember to simplify. 3 over 3, like a fraction, is 1 over -1. And then my factors come from these two sides. This first side gives me a factor of 3x minus 4. The second side gives me a factor of x minus 1. Make sure that you bring down the equals 0, because we're now going to use the power step that everybody loves. This is called the zero product property. The zero product property, as I write it, says if we are multiplying two things together and the answer is 0, then we can be sure that either the first thing we're multiplying equals 0 or the second thing we're multiplying equals 0, which means our two solutions come from each factor and setting it equal to 0. From here you can solve. Add 4 and divide by 3 would give you a fraction of 4 over 3. Notice that the answer is not the fraction from the snowflake. Don't stop here and take those as your answer. That will be a common mistake. That will be on the multiple choice test as a common mistake. This is the actual answer. Finish the problem all the way to getting x by itself. The second solution, of course, is x equals 1. We'll pause at this point while you do the example problems on this page. When you're ready to see the answers, press play again. Here is answer A. And B. C. And E. On the next page, there are a couple last quadratic equations, so I'll turn to those now. There's nothing terribly different about number 5, except that you will notice that not all of your terms are on the same side. So you will need to set the equation equal to 0. In other words, you need to move all your terms to the same side. For me, that's going to mean subtracting the 3x and adding the 5. My tip for this would be always move everything to the side that has the x squared. It's preferable not to have a negative coefficient for x squared, although you could do it if you really work through the snowflake correctly. When we move everything over, we get 2x squared minus 3x plus 5. Notice how the signs change because I'm moving them over. Technically, minus 3x plus 5 plus 5. Now that I have 0, I'm going to go ahead and try the snowflake method, because preferably I would like to factor this. It's the quickest way to solve. When I set up the snowflake, I see that 2 times 5 is 10, and I'm looking for two numbers that multiply to 10 and add to -3. Now I'm tempted to say that -5 and 2 will work, but the problem with -5 and 2 is that when you multiply them, this would give you a -10. And it's not supposed to be a -10. It's a +10 when you multiply A and C. So the truth is you actually cannot factor this, even though it looks really tempting. Well, good news is you know what to do when you can't factor. Hooray, quadratic formula. I recommend doing the quadratic formula in 4 steps, but take a moment to identify A, B, and C so that you don't accidentally mess up your negative symbols. The 4 steps look like this. We start with -b, so flip the sign of whatever was in the equation. Plus or minus, square root. In the front of the square root, you do b squared. In the back of the square root, you do -4 times a times c. Negative times a positive means my answer is going to be negative. 4 times 2 times 5 would be 8 times 5, which is 40. And on the bottom you have 2a, which is just 4. Notice how little work it is if you think about it in those 4 steps. You do need to simplify. So we get 3 plus or minus the square root of negative 31 over 4. Bells should be going off in your head because a negative inside of a square root is either no solution or we would treat it as a negative I, or a negative inside the square root is I, not a negative I. So that negative means that our solution is really 3 plus or minus the square root of 31 I over 4. This could also be written as 3 over 4 plus or minus root 31 over 4. Either format would be fine. However, make sure that the 4 gets distributed to both fractions. Don't simply simplify one or the other. For the last problem here, you're going to want to move everything over to one side. I'll let you do this one on your own. I think it's pretty self-explanatory. When you're ready to see the answers for E and F, continue to press play. Here's E, and here's F.